Alright. Hello again. Just got home from work and some errands. But standard cordless drill. Issue I've been having is that the clutch on this, if you're not familiar, you know, that's where you have all these different numbers, and it's supposed to change it so that when you are tightening something, when it's on the number settings, it will actually, when it hits a certain amount of resistance, it will stop turning and it will slip. What I'm finding is that even on the drill setting, if I tighten it down, you know, if I run it all the way, that I should not be able to stop this. But that sound is actually the clutch inside where the motor is spinning inside the gearbox. And it's annoying. I originally mistakenly thought it was the chuck at first, and so I replaced that only to, you know, have it still do the same thing. So tear this apart. As is usual with these things, you know, it's a bunch of plastic. Like, I've never taken a drill apart. They're not particularly exciting devices. I did have a little bit of a hard time finding the part. I had to search for the specific model number, but then it's a generic part, so that doesn't match with the exact part number. And then there's replacement part numbers because they've changed the part and refined it over time, and it's kind of common in these, in a lot of products. They do that in cars too. But I eventually figured out, like, they're available, they're on eBay, just had to get the right part number. But I have a couple of these older 18-volt DeWalt series, the DC 759. They all came in a kit, and I like it as a general purpose drill. I also have the impact gun that I use quite a bit, the impact driver. Actually, probably use the impact driver a lot more. Okay, so as I said, there's not a whole lot in a modern cordless drill. These are the battery input terminals, and as far as, you know, these things, it's 18 volts on the two sides of the two prongs. It goes into the actual switch here, and the switch mechanism is just this thing. It's just a molded block, and that actually controls the connection of both terminals through there. It's all one big unit for controlling that. And the output goes then through directly into the motor. Now this actually, part of that reason that's a big block is this has variable speed, so it's not simply an on-off, it's actually more like a potentiometer that when you pull it in slightly, it's going to regulate how much power goes through it. I don't think it's actually a resistor inside here, but I'm not going to take it apart right now. The piece I'm care about is after you get through the motor leads into a gearbox that actually, when you get a lot of torque on something, usually what you do is you spin a motor at a much higher speed, and it's easier to get a DC motor to spin very quickly than it is to turn slowly with a lot of torque. Essentially, if you think of how a motor works with windings, in a DC motor, or at least in a brushed DC motor, you actually need there's a pair of brushes. So if you think of it this way, there's a pair of brushes that push on the stator that rotates inside, and one's positive, one's negative, and the current will flow through the coil, and that causes it to turn around inside the motor. And at low speeds, that will happen. It will change between coils very slowly, and it actually means you have to have a lot of current going through the motor for a long time, whereas at high speeds it's actually not having to put any particular coil inside of there is not particularly busy because it's just rotating very quickly. So they use a high rotational speed and then use a gearbox to actually lower that speed and get all the torque out of it. So it's a pretty common application. Dyson does this a lot too. They run, if you see their vacuum cleaners, basically they run a brushless motor at really, really, really high speeds, and then can gear that down and do other things with it. Pretty common. So this gearbox is all attached to this whole assembly with the selector switches and everything. So it has two different gear ranges, and that's what this selector does. And I don't actually know how this all comes apart. Apparently like that. So I'm gonna have to take the chuck off that I put on there. So things on drills, they're pretty simple component-wise, and they're quite repairable. You don't actually have to toss them out. And the chucks actually are one of the pieces that are more commonly available. Most of these drills use a half-inch thread with I'll show you right here. I got this interesting new assembly. So here you've got the actual input gear assembly. So the motor has a simple, single pinion gear on there, and then it has a planetary. It's a planetary gearbox inside that feeds in the overall gearbox. And on the other end of it, you have where the chuck actually attaches. This thread pattern, it's a half-inch, it's a half 20, so a half-inch bolt with or rod with 20 threads per inch for the thread pattern, and that's a very standard thing. Now on these drills, the stock Jacobs the chuck actually has a bolt that goes in through, that's not a bolt, it's a cap screw, but it goes in through and screws into the center part, which is why that's tapped as well. And that way you can tighten it down and then actually torque that in, and they will often put Loctite or something else on that to prevent it from coming loose. But a lot of aftermarket chucks don't actually use that. They simply attach just by force. Do I have a plier that can deal with this? I don't even have a plier that's big enough right here. Go grab a different plier. So of course when I installed this, I was on a workbench in the garage, and I have a lot of space that I can turn it, and I torqued it down very strongly. Now I don't have that luxury. Put that back on there. So I'm just trying to put it back on to hopefully use the motor and the overall handle assembly as a way to hold this while I try to twist that loose. No idea if I will succeed. I did a good job putting that. I did not Loctite it, which is probably a saving grace. There's a slight chance that I'm turning that the wrong way. There we go. So, like I said, friction fit. So, it's pretty. This one is a made by ROM. My children are coming. Hello. Okay. Slight interlude there. Yeah, so this is by a company called ROM. They're a German company, and they make some really nice chucks. They're primarily all metal, whereas a lot of like a Jacobs chuck has a lot of plastic components in it, and some other. I mean, everybody offers plastic ones now, but anyway, the all metal ones are often used on impact drivers and rotary hammers and things that are going to be under a lot of torque. So even though this wasn't actually the problem, because I went ahead and bought it, I may as well put it on here. It's a very nice chuck. And as far as why replacement chucks are so common and available, you use them in lots of different applications. Like replacing them on a drill like this is moderately common, but drill presses actually can have them swapped out. They go in a taper usually. Same with lathes, mills, and like when you have a rotary hammer, they often take specialized bits on a rotary hammer, and what I have found with those, what you can do is buy a attachment that fits into the rotary hammer chuck for the special drill bits like the SDS Plus or things like that, and that just have that same half 20 pattern on it for the bolt and or for the threading pattern. And when you use that, then you can put a standard drill chuck on it, and so you can actually use standard drill bits with the yeah, you can use your standard drill bits with the like an SDS Plus rotary hammer. Now this clip popped out, and I have no clue where it came from. It's like almost a completely different design. I think there was it's molded plastic. That came off without an issue. Okay. I don't know what that was for. Doesn't seem like a wire. That goes into a molded slot there. That's going to go into a molded slot. Doesn't seem like it has any function there. There. That's fine. That's the spring-loaded detents. That's there's nothing that could fit there. As far as the motor goes, one would expect that this has a purpose. I just have no idea what it is. doesn't really fit around that pin. Let's go to pivot. Oh no. I hate this. See this? I didn't even notice it at first. So these stupid little anti-theft tags, they actually put it inside the drill assembly. So even if it's not inside the case of, you know, like the kit or inside the box, it's actually inside the tool. And those things always alert whenever I go out of a store. I'm never stealing something. And when I purchased one of the detectors for a project at work, I played with all the tags. Turns out they're pretty trivial to defeat. So I think it was less than 10 minutes after they had installed it. The vendor and the contractor had actually spec'd out the whole site that just took apart the actually it was my boss at the time who was really curious because we bought this expensive theft prevention system. We wanted to see how well it performed, and he immediately found a way to defeat it. So, those things are there as a deterrent. They are not a replacement for anything, and yes, everybody knows that they don't work particularly well if you intend to actually steal things. The boring part of reinstalling the screws. I don't know how many people actually watch these things. I haven't paid any attention to comments or see if anybody even watches the older ones. I'm just kind of doing the things that I have around on my workbench. I don't know if there's specific topics people want to see, if there's more live coding that you're interested in versus whatever. But the chat's available. I guess I'll try to make an attempt to look at the comments. I generally avoid comments, and I understand the irony of that coming from somebody who works at Google. Alright, hopefully. Well, that's not good. Uh-oh, friends. It wasn't the clutch. What is making that noise? Got a few projects I'm meaning to get back to. I'm trying to get my new business website up and running now that I've got most of the legal paperwork filed so I can actively sell things. I've got a small pile of the interface cables I made for these Motec ECUs, the gold box, M48, M4, M8. And I need to figure out, how to package them. Do I just put them in a? Anyway, I finished assembly finally, and I believe they work. But a new acquisition recently was somebody was actually selling one of these on eBay at a reasonable price, only $500. So. But in usual fashion, they just cut the entire harness. So I get to spend a little time building a new wiring harness for that, so that I can use that as my debugging and test board or test module. Build up better tools. Okay. So we know I just replaced all of that. What is going on? No, that didn't slip. Maybe what happened. Okay, so we put that together. Oh, I didn't get the other side together. There's two sides to that that have to go together. Lots of things not going right now. Okay, well, that gets the switch in the right way. That gear selector's down. And that's just weird. It might be fixed. So at least try putting the halves together so I can hold it. Huh. I need me a new selector. Old wheel. I like the old one. Tools should have patina. Cars, not so sure. But tools should have patina. Now what is going on? It just really doesn't like that high speed range. Low speed range seems okay. What's happening? It's in the high speed range. Oh. It is this little gear selector not getting fully engaged. That's weird. Okay. Yeah, look at that. It doesn't actually engage fully. What's holding it up? I'm supposed to go back just to hit more. That's bizarre. So when it's in the low gear range and this moves forward, it seems to behave perfectly fine and has, you know, massive amount of torque. But when I put it into the high gear range, which, I mean, I don't expect it to have a ton of torque in the high range, but I don't expect it to spin the gears like that. It seems that the I mean, that's the new gearbox. There's just something not right about how that gearbox behaves. But it happens on both. Unless I bought a broken bum clutch, but there's sold a new one. Well, used old stock. There we go. No. Sometimes it works and sometimes it doesn't. I wonder if I've ruined the pinion here. I don't actually know. How I would figure that out. Of course, the drill battery is about dead now. It's very strange. It doesn't appear worn, but I guess it could be. It would be under a lot of load at that point. So it's when this is pulled back. Something I don't really understand. It's not supposed to slide back. Yeah, that's actually inside the gearbox that's slipping. Oh, it killed the battery. That's weird. That's really weird. So I'm making an educated guess that this is actually a spring to push the this piece down, but I'm struggling to figure out how that would work. Oh, like that. Yeah, that tensions it pretty nicely then. Okay. Seems okay. Well, this may be only used in low gear drill now. And it might be time to start retiring them and moving up to their new lithium-ion ones. And brushless. Brushless ones. Okay. So, since I have this one here, I wonder how it all actually goes together. See, a set of pins there and there, and a sign that sort of indicates it comes apart that way. So, I'm primarily curious as to how that actually slips internally. So here we have that taken apart. So we basically have two totally independent gearboxes. You know, this has the gear coming into this planetary assembly here, with the actual gear speed selector here. Then that output shaft is then driving the actual clutch assembly here. And that seems like it's just going to fall right out. So, okay. I don't know if that's everything. Ooh, ball bearings. I'm going to have to clean my bench after this. And hope that my dog does not eat things. It's a D10 spring. Okay, so that is the whole piece there. And when you rotate this, what happens? I can see how the ball bearings get applied. I don't understand how the collar works. Can't tell. Okay, all right. So as you turn the clutch like this back half actually separates a little bit, and that's on a set of channel that changes the height of these pins that have so those pins, when I rotate it out, they actually recess and come back and then go in. And those are where these ball bearings actually sit. So that ball bearing, see that? So, I always forget where my camera is. Right, so there's the ball bearing, and it sits in that little cup on there. And so that's going to change the tension that that ball is placing on these plates inside here. So there's this plate that has these ridges, and so those balls are going to be pushed extra hard, and it's going to take more force to allow it to slip past when it's torqued down. So basically, you know, at the low clutch settings, there's not going to be much tension on it, and the ball can actually ride over the ridges, and that's the slip. And the rest of this just seems to be a way that each one of these gears is, you know, it's directional. so it won't turn that way. There's probably a reverse somehow, something I'm missing, but okay. So there's those little pins in there, and there's this piece that holds the actual planetary gears, and so this gets turned and it rides on the outer ring. I'm not going to put this thing back. So, okay, so that explains how the clutch works. It's basically those ball bearings get tensioned against the plate, and the spring loading on them, the amount of force loading on them determines whether it gets to go past or not. I'm not really understanding the point of this piece. I get the balls and that, and there's the center spindle there, which fades into this piece, which I get all that. This must just be a set of, oh, it's a set of bearings to, they're just roller bearings to hold it in place. And they have, I don't know why they aren't engaging the reverse direction. Feels like they should, but maybe not. So that's the clutch. That's kind of cool. And assembling this, I bet somebody does it by hand, because ball bearings and everything. Okay. Sure, why not? I'll put the detail back in too. I don't know why I'm bothering to reassemble this. I just threw all the ball bearings everywhere. And all those pins went everywhere. Oh man, it's a mess. Yeah, it's chaos in here. Alright. Okay. It's gonna go in the trash. Alright, so how does this gearbox work then? So I've got that plates. And that's a plate that looks to be held in a little bit. Okay. Is it plastic? What's on this there? Oh, there you go. Okay. So So there's these set of ring gears. Yeah, there's a ring gear and a set of I'm just gonna pop this whole thing out. There we go. So there's what we got. So there's these two separate pieces we've seen before. Basically, it's got a pinion there, and it's got 3 places for these outer gears to run inside of a ring. And then in this case, those are mating onto another pinion that has another set of outer gears. And what it seems to be doing, it's kind of hard to see. There's 2 separate sets of plastic teeth in there. And so the lever that's here, when it engages, just moves one set of plastic teeth down. And then it slides back up. So what I'm seeing is that when I put it into this gear, like the edge of those plastic teeth, oh man, that's so hard to see. Basically, this edge right here of these plastic teeth are worn off. So what was happening was, when it was engaged this way, it was just grabbing, or maybe when it was partially engaged at some point. Or something, and yeah, so when that's pulled back, and those gears are supposed to be engaged on that outer ring here, instead of here, which is going to be reduced. The gearbox is just missing, and it's chewing up those gears. I suspect this just has a real hard time wow. Very confused by that. So yeah, when that's set, like right now, well, there's no way to see that. So there's the set of pins, and those planetary gears are going to ride in a ring that's on the outside here, and that's going to drive that center stake. Actually, that's what's being driven there, and it turns those gears against that outer ring, which turns this inner piece. But as that turns, like right now, those are pretty well locked. And when the gear gets changed, it rides on the planetary gears, which are going a lot faster. But yeah, when it goes to engage the other direction, it can still catch. It's just not engaging well. Yeah, you can see there, sort of. When it's, so this would be the high gear range. And so these gears and that center gear are locked. They're all locked together and supposed to turn together. And when that gear gets moved into low gear, it slips off that outer locking ring there and just runs on these ring gears, or the planetary gears, which is going to reduce the speed. So when I'm having trouble actually engaging it and getting high gear there, it's actually just that one gear isn't fully engaging enough. And I bet what's happening is it's like getting sideways cocked or something. Or just not, it's just like jamming. I mean, the design should work, but experience is saying it doesn't always. Huh. Fascinating. Well, so that's how the gearbox works on one of these drills. Sadly, it seems I had the same problem with the new one. And I don't really know how to fix that. Because it's definitely inside the gearbox, but it seems like a design flaw in the gearbox. Or somehow the gearbox stopped being aligned. I don't know. Okay. I gotta clean up this whole mess. I gotta stop doing greasy things on this desk. Alright. Let me clean up stuff. So this will be my usual spiel that I mostly do on Twitter. So I am very active on Twitter. I do have my DMs open, and I respond to them pretty promptly. I also follow, so Stephanie Hurlburt started the whole getting people who actually are willing to help and mentor to show themselves on Twitter and make it known. So if you go to my Twitter profile or my Twitter bio, you'll see a link to a Calendly tool site that you can schedule a 30-minute session with me. I usually do Google Hangouts, and they can be pretty open-ended as to what we do. A lot of people recently have been using the mentoring option and really just kind of want to have a chat about different parts of the industry as far as software development and embedded systems, and kind of just the lay of the land for working in industry in computing. A couple of months ago, people were much more interested in doing mock interviews. I suspect that had to do a lot with people preparing for end of the year type interviewing. But anyway, I'm happy to do either. There's also, I probably should just add another option for like general chat session about whatever. But they're available, 30-minute slots every Thursday pretty much. I'm Pacific time, so that's when it pretty much shows up. It's Thursday morning for me. But if you would like a different time, feel free to just message me and we'll figure it out. I have a pretty flexible schedule. And as far as projects going, I've got a lot of things on my desk that I need to actually work through. I have a couple different projects. I have a rubidium oscillator that I've had for probably 2 years that I need to build an adapter board for, and then use that as a GPS disciplined clock and time and frequency source. I actually want to do a lot of complicated things with that. I have the ECU and doing some more work on reverse engineering that protocol. I have a couple more teardowns kind of things. Going back to vintage cars, I actually have a mechanical voltage regulator out of a Ford, like a 60s Ford. I have also the upgraded electrical version of a ignition system for the same, so it replaces the points system. Has some miscellaneous EEPROMs that I found in a creek bed outside my house. Yes, that's part of living in Silicon Valley, is apparently just finding random electronics, electronic components scattered around. Yeah, variety of things. But I'm also trying to get a business started. We're selling some of my electronics components. So, like I said, I'm been working on these USB cables that do meet up to the Motec serial interface on these older devices. It's not very complicated. It took a little bit of time to figure out what they were doing, but it's the details are all on my blog as to how that actually works, and if you're capable of soldering a few wires, you can make your own. It really isn't a big deal. I just decided to have a bunch of PCBs made, and I will sell what's there, and if people like it, I will continue to sell more. After that, I'm not sure what I'm going to do product-wise. I have a few different ideas. My goal is to actually sell things in the engine electronics, sort of automotive electronics space. Not so much. I don't really plan to get into infotainment or anything, but definitely engine control, sensors, transmission control, things like that. And definitely more focused on like motorsports and not your daily driver type stuff. So if anybody has any ideas or is interested in doing things there, that'll be cool. My daily work is actually around FPGAs, and I have a few floating around. So I will be hopefully getting back to that soon. Now that I know more people that do FPGA things. So this is actually the Tiny FPGA B2. I heard one of these. So these are Lattice ICE 40 FPGAs. And the cool thing is, like, this thing, I mean, when they say tiny, Luke means it. This thing is, jeez. Reference, here's a 2.5-inch hard drive. I mean, that's tiny. And the actual FPGA is that thing. So anyway, I want to use one of these. I want to build an LED matrix video wall thing. And I actually have a whole bunch of panels, they're kind of hidden, that I bought a while back of 64 by 128 RGB panels that I'm going to figure out all the powering and everything on that. So maybe sketching out the design there. It's probably going to be a little complicated design. I think I know where I want to go with that. But anyway, I think that's it for now. I'm going to go work on my website for a bit. And yeah, if you have any comments, things you want to see me do, work on, just let me know. I mostly have been picking up whatever comes to mind, but can certainly steer things a different way if you like. All right. Good night.